Today we're learning how to calculate pH and hydronium ion concentration. The reason that we are learning this is that we want to be able to determine how much acid is in a solution, and our success criteria is being able to calculate pH, hydronium ion concentration, and mass from each other. So with our definitions of acids and bases, what we know is that sometimes water can act as an acid or as a base. This might seem weird, but it's actually by acting as a very, very, very weak acid and a very, very, very weak base. So there is a chemical reaction where two water molecules can react with each other. One water molecule gives up a hydrogen ion, and the other water molecule gains a hydrogen ion. This creates a hydronium ion and a hydroxide ion. Hydronium ion is what makes things acidic. Hydroxide ion is what makes things basic. Now, at standard ambient temperature and pressure, these concentrations are very, very, very low. They are at 1 times 10 to the power of -7 moles per liter in absolutely pure water. You'll also notice that we have a double-headed arrow here. What this means is this is also a reversible reaction. The hydronium and the hydroxide ion can come together and neutralize, as acid and bases do, turning them back into water. And at SATP, over 99% of the time, that is exactly what happens. The hydronium and hydroxide ions will neutralize each other as soon as they're created. But there is still a very low level of concentration of both compounds in water at all times. When we calculate the pH of a solution, what we're doing is we're figuring out what the exponent on that concentration is. pH is specifically for hydronium ions. In the next video, we'll talk about something called pOH, which is for hydroxide ions. What pH stands for is it stands for the power of hydrogen. Now, we know it's not hydrogen that makes things acidic. We know it's hydronium. So you can put a mental note next to that and say it really means power of hydronium. What power are we talking about? We're talking about the exponent. If you've ever wondered why water has a pH of 7, this is why. 1 times 10 to the power of -7. That 7 is the same 7 as is in pH. What the pH scale is doing is it's reading the negative exponent of the hydronium ion concentration. So our pH will be equal to the negative log of the concentration, and it's the negative log, which is why 7 on the pH scale is a positive number. If we want to figure out from the pH what the hydronium ion concentration is, it's just equal to 10 to the power of negative pH. So if we know it's 7.3, then we can raise 10 to the power of -7.3 and find out what that concentration is. Important thing to remember as well, concentration is in moles per liter, and if you know the moles per liter, and you know the volume, and you know the molar mass, you can use that to figure out what the mass of the acid originally was.